Sila'y kaibiganin at kayo'y magtataka, mundo'y mas mauunawaan. Halina, sumama na kayo, maglakbay, mag-enjoy, maglaro, tuklasin ang math sa buhay natin. Dali na, mag-math na tayo. Halina, sumama na kayo, maglakbay, mag-enjoy, maglaro, manaliksik, maging Mathtinik.
If scripted yung buong April Fool at the Peach Connector, as someone who loves being outdoors,
I am building a Guys, yung binili kong damit na iwan ko sa ABC Mart.
Tap na ako.
O class, keng Thursday na tintang quiz. Di mapangopyagen, mamag-review lo.
Huwag ka na mag-review. Matulog ka na lang ulit. Makakapagpahinga ka pa. Sasakit lang ulo mo dyan eh.
Gising na, Aaron. Mag-review ka na. Kailangan mong bumawi. Huwag kang makinig dyan.
Hindi! Mangupya ka na lang. Kayang-kaya mo yan.
Gising na. Di ba pangarap mong mag-top 10 sa board exam?
Ano kaya ang gagawin ko? Magre-review na ba ako? Matutulog pa? Review o tulog?
Review, review, review.
Good day and welcome back to our channel for another chapter of making math hirap to math dali. Our chapter for today focuses on the shear and moment in beams, a fundamental topic for engineers, specifically for the civil engineers. So before we proceed solving different problems, we need to be familiarized with the different terms that will be involved all throughout the discussion. So first is yung beam. Beam refers to a slender bar designed to bear loads perpendicular to its length, known as transverse loading. And in that said beam, there is an internal force that consists of a shear force and a bending moment na nag-a-act sa cross-section ng beam or yung bar. So, internal forces in beams produce two types of stresses on a cross-section: bending-induced normal stress and shear stress from shear force. So, moving forward, there are various types of beams and supports. But for this chapter, magfo-focus tayo sa mga statically determinate types of beams. But what is statically determinate means? So, statically determinate means that their support reactions can be computed or distinguished from the equilibrium equations. So, the following are considered statically determinate beams: simply supported beam, cantilever beam, and overhanging beam. So first is yung simply supported beam. As we can see sa figure, meron siyang dalawang support, which is the pin support and the roller support. The pin support restricts movement of the beam's end but allows rotation. On the other hand, yung roller support, which features a pin connection able to move along the beam's axis, only limits sideways displacement. So next naman is yung cantilever beam. As we can see ulit dun sa figure, yung support nasa left end but wala siya sa right end. The anchored support not only prevents displacements but also restricts rotations at the end of the beam. And lastly is the overhanging beam. It is supported at 2 points. As we can see, nasa gitna yung dalawang supports, but usually at one end and in the middle and not on the other end. So, moving forward, meron tayong types of loads na may encounter during our computation part. And these are, ayan. So, ayan yung mga types of loads na aaralin natin. So, for number 1, that load is called a concentrated load. It is a force supplied at a single point or over a very small area, resulting in a significant force exerted at that precise location. So, ibig sabihin nung sinabi ko na yung sa number 1, yung load na yon naka-point lang siya or na-apply lang siya sa isang point, sa isang place, or sa isang exact location. Unlike dun sa number 2, yung load na yan is tawag dyan is distributed load. Dun sa nakaganyan, it is called uniformly distributed load, while the slanted one, it is called linearly distributed load. So, distributed load is applied over a finite area. Hindi siya katulad ng concentrated load na nakalagay lang siya sa isang specific point. So, next naman is yung sa number 3, concentrated moments. Concentrated moments tend to bend and rotate the beam. So, as we can see, pag ganun siya, iikot siya. So, yun. So, we now proceed on the shear and moment diagram. Paano tayo makakasolve ng reactions from the different supports? So, for method of sections, from the name itself, section. So, it determines internal forces at specific points along a beam by cutting it or sectioning it by segment and analyzing free body diagrams. So, for example, ito yung beam. Itong buo yung beam. So, by section, ikakat muna natin to para ma-determine natin if alin yung mga internal forces or ano yung mga internal forces na nag-a-act dito. So, next method naman is method of areas. Yung method of areas, una is gagawin mo, i-compute mo yung reaction sa mga support, and by that, yung mga values na makukuha mo, you will determine na sa shear force diagram if sa taas ba siya ng x-axis or sa baba siya ng x-axis, which will determine if positive or negative yung reaction. And dun sa mga na-compute mo sa shear force, i-identify mo yung area ng mga yon and yung mga nakuha mong values sa area nila, dun magbe-base yung makukuha mo sa moment. So, yung diagram na to and yung computation, mas maiintindihan nyo siya sa actual application sa mga problems. And yun. So, next, ito yung magiging basis mo sa method of area if paano mo siya i-compute, if paano mo i-consider yung degree, yung line, and yung signs. So, merong concept dito na yung shear is mataas siya ng 1 sa load and yung moment mataas siya ng isa sa shear. So, dun sa unang type of load, yung concentrated load, makikita natin na non-degree yung load niya. And sa shear naman niya, which we add 1, magiging siyang 0 degree and add another 1 for moment, kaya siya naging 1 degree. Tapos, yung next naman is yung uniformly distributed load. Yung load niya is 0 degree, yung shear niya 1 degree, then yung moment niya 2 degrees, and so on and so forth. So, dun sa last naman, makikita natin na naka-curve siyang ganyan. Tapos, makikita natin na yung value niya is n degrees. So, n degrees, kaya siya nilagay na n because it is unknown. Unknown siya dahil it is not specific if anong degree yung pagka-curve niya. So, yun. Next naman is sa tension. So, 2 and 3, makikita natin na curve sila, obviously. And yung 1 is line. So, sa 1, para ma-determine natin na positive yung slope, it is rising pataas. And yung negative slope naman, it is going downward. Then, sa second degree curve, malalaman mo na increasing siya or i-consider mo na increasing siya if the line or the concave is opening upward or a smiley face. Same lang siya sa third degree na malalaman mo na increasing siya if it is a smiley face and decreasing naman if it is a sad face. So yun, ito yung mga kailangan nating tandaan na terms and concepts.
Ngayon, tayo magpapatuloy kung paano masolve ang easy problem about shear and moment by equation and area method. Prepare your papers and pens at sabihin nyo ako mag-solve. First, we need to calculate the moment at A of the beam and the reaction at segment AY. So let us proceed in getting the value of moment at A. Summation at moment at A is equals to 20 multiplied by 4 plus, and positive siya kasi it moves clockwise to point A, then 30 multiplied by 12, and you will get the value of moment at A. Now, what is the value of moment at A? A. 350 kN meter. B. 440 kN meter. The answer is B, which is 440 kN meter. Next, kunin naman natin ang value ng segment AY. AY minus, and bakit siya minus? Kasi yung arrow na naka-point ay pa-downward, then 20 minus 30 is equals to 0. Then makuha mo na yung value at segment A. Now, what is the value of segment at A? A. 50 kN meter. B. 34 kN meter. The answer is A, which is 50 kN meter. After getting the directions of moment at A and segment AY, the next step is we need to cut the segment of the beam into two parts, which is the segment AB and segment BC, and get the equations of the segments. At segment AB, the values of the forces are 50 kN meter, which is the value of AY, then the value of our moment at A is 440 kN meter, and our shear moment at AB will go downward. Summation Fy is equal to 0 upward positive. 50, which is the value of our EY minus shear moment at AB, is equal to 0, then our value of shear and moment at AB is equal to 50 kN meter. Then, next is our moment at AB. Summation of moment AB equals 0 clockwise positive, and our moment at AB is equals to positive 50 multiplied by x minus 440. Now, let us proceed at segment BC. Shear moment at AB will go downward, and the value of moment at A is 440, and the segment A is 50, and the 20 kN, which is the concentrated load that's given in the problem. 50 minus 20, shear at BC is equal to 0, then the shear at BC is equal to 30 kN. Therefore, the moment at BC is equal to 50 multiplied by x minus 20 times x minus 4, then minus 440, and that is the equation in the moment BC. Now, in solving for values at segment AB and segment BC, at segment AB, shear at AB is equals to 50 kN, therefore, x is equals to 0, and moment at AB is equals to negative 440 kN meter. Then in moment at AB is equals to negative 240 kN meter. In segment BC, shear at BC is equals to 30 kN, therefore, x is equal to 4, and moment at BC is equals to negative 240 kN meter, and the next is x is equals to 12, and moment at BC is equal to 0 kN meter. Ngayong tapos na tayo mag-solve, pwede tayo mag-proceed sa pag-plot ng shear and moment diagram. In plotting the shear diagram, we don't need to consider the moments, we only need the forces along the y-axis. As you can see, dahil may upward force na 50 kN sa AY, i-plot natin ang positive 50 sa graph. And because there is no force acting along the segment AB, straight line lang ito. Next, since may downward force na 20 kN sa B, minus natin ito sa 50. 50 minus 20 is equal to 30. I-plot natin ang 30 sa diagram. And because there is also no force acting along the segment BC, straight line lang ulit. Lastly, mayroong downward force na 30 kN sa C, kaya ma-minus natin ito sa 30 na plinat natin kanina. 30 minus 30 is equals to 0. And that's it. Tapos na ang ating shear diagram. Next, let's proceed in plotting the moment diagram. Ang first moment natin, if x is equal to 0, ay negative 440 kN. If we look at the figure, nanggaling ito sa 440 kN na counterclockwise moment, at since counterclockwise siya, kaya naging negative ito. Next, if x is equal to 4, the moment is negative 240 kN. Unlike in plotting the shear diagram, imbes na straight line lang ang ginamit sa pagkoconnect ng points, sa moment diagram, slanting o diagonal line. Lastly, if x is equal to 12, the moment is 0 kN. From negative 240, i-connect lang natin ito sa 0 using a slant line. And that's how you plot a shear and moment diagram using by-equation method. Aside from solving the shear and moment diagram by equation method, meron pang isa at mas madaling method na pwede nating gamitin, and it is the by-area method. In this method, like in by-equation, the first step is to solve for the reactions. After that, you need to proceed in plotting the shear diagram right away. The next step is to solve for the areas, pero paano natin gagawin yon? In this case, the first shaded region is area 1, and the second one is area 2. In solving the area, alam naman natin na it is the measurement of the surface of the shape. Look at area 1. The shape is rectangle, and the formula for getting the area of a rectangle is to multiply its length by its width. Ang length niya ay 50, and ang width niya, which is the distance, is 4. So 50 times 4 is 200. Next, since rectangle ulit ang second shaded region, length times width ulit. Ang length nito at 30 at ang width niya ay, which is the distance, is 8. So 30 times 8 is 240. From these values, we can plot the moment diagram na. First, plot the negative 440 kN moment. After that, combine natin ang nasolve nating value ng area 1, which is positive 200. So, negative 440 plus 200 is equal to negative 240. As you can see, same pa rin ang na-plot nating value using by equation. Next, i-combine natin ang negative 240 to the area 2, which is positive 240. Negative 240 plus 240 will equate to 0. Ganun lang kadali.
Let's solve for the reactions and areas using area method for this average problem. For the first step, we get the summation of moments sa support D, which is equals to 0 considering clockwise direction as positive. So first, 3,000, which is considered as couple moment. Kapag couple, hindi required na kunin ang distance kung gaano siya kalayo sa D, kasi moment na siya. It is positive dahil yung ikot niya is clockwise. Next, positive AY. Yung positive is just an assumption na upward yung direction siya. If nakuha ang answer is negative, dun natin malalaman na mali ang assumption natin. Multiplied by 8 kasi ang distance niya from point A to D is a total of 8 feet. Next, negative 2,000. Negative siya kasi yung turn niya is counterclockwise or nasa left ng D, going downward direction, tapos multiplied by 5. Kasi yung distance from point B to D ay total of 5 feet. Next, negative 500 kasi turn niya ay counterclockwise. Given na yung load na to is a distributed load, need kunin yung resultant by multiplying the load sa distance na nasasakupan niya, which is 3. Then dun siya imumultiply na sa distance niya, which is 1.5. Hindi siya 3 kasi kapag may distributed load na present, kailangan kunin yung gitna nito, and hindi yung buong distance. and everything is equals to 0 equilibrium. Ngayon, tatanungin ko kayo kung ano ang tamang sagot. AY is equals to letter A, 1,000 pounds, or B, 1,150 pounds, or C, 1,156.25 pounds. The correct answer is C, 1,156.25 pounds. So yung nakuha nating sagot is positive, which is tama yung assumption natin kanina na yung AY is positive going upward direction. Next, magmo-moment naman tayo sa point A. Again, 3,000 plus 2,000 times yung distance na 3 plus yung resultant na 500 times 3 times 6.5 minus dy times 5 and equate ito sa 0. So dy is equals to 2,343.75 pounds. Now, that complete ng forces natin, proceed na tayo sa shear diagram. Start sa upward force na 1,156.25, then straight line, subtract 2,000, mag-equate to sa negative 843.75. Next ay add ang distributed load, magiging negative 2,343.75. At ang upward force sa segment D, so magzi-zero ito. Ngayon naman, solve na natin ang mga area per shape. Sa area 1, since rectangle ito, 1,156.25 times 3 equals to 3,468.75. For area 2 naman, meron tayong negative 843.75 times 2 equals to negative 1,687.5. And lastly, for area 3, trapezoid ang shape niya. Kaya 1/2 times the quantity, negative 2,343.75 plus negative 843.75. Then multiply to 3, this will equate to negative 4,781.25. Plot na natin ito sa diagram. Start tayo sa positive 3,000 because merong couple moment sa point A. Then add the area 1 to 3,000, mag-equate sa 6,468.75. Then add ang area 2, so this will equate to 4,781.25. Then combine din ang area 3, so magre-result ito sa 0. Yun lang para sa ating average problem by area method.
Let's now proceed to the difficult round and solve the last problem for this video. In this problem, we will use area method in graphing the shear and moment diagram. Handa na ba kayo? Just like how we solved the previous problems, the first step is to always solve for the reactions. First, isolve natin ang moment sa E. Multiply natin ang downward force sa A sa distance nito sa E. At since counterclockwise ang magiging direction nito, it is negative. So it will be negative 50 times 15. Then there is a couple moment given which is also counterclockwise in direction, so it will be minus 120. At dahil nagmo-moment tayo sa E, makukuha natin ang missing reaction ng support sa B. And since clockwise ang direction niya, therefore it will be plus By times 12. Next, in the case of uniform load, kailangan muna nating i-multiply ang 20 kN per meter sa distance nito para makuha ang force sa gitna ng loads. At since counterclockwise ang direction niya, it will be minus 20 times 6 times 6, which is the distance from the center of the uniform load to E. I-shift solve lang natin ito sa calculator at makukuha na natin ang By. Tama, B, 132.5 kilonewtons. Now that we've solved the reaction at By, isa na lang ang hinahanap, which is the reaction at EY. Para makuha natin ang reaction sa E, kailangan nating mag-moment sa B. First, since counterclockwise ulit ng direction ng A, it will be negative 50 times 3, minus the counterclockwise couple moment 120, plus the 20 times 6 times 6 again, just like what we did previously. But this time, it is positive kasi clockwise ang direction niya. Minus EY times 12 equals 0. EY is equal to, the answer is 37.5 kilonewtons. Parehas ba tayo ng nakuha? After getting the reactions at By and EY, we can now plot the shear diagram. you can pause this video and try to draw the shear diagram on your own, then we can check after if you got the same answer. There's a downward 50 kN force at A, so i-plot na natin ang negative 50. Since walang force acting along segment AB, straight line lang siya. Tapos, mayroong upward force sa B, so i-add natin siya. Negative 50 plus 132.5 is 82.5, at ito ang ipa-plot natin. Since wala ulit force acting along segment BC, straight line lang ulit. Then, ang total ng uniform load na ito ay 120 kN. At dahil uniform load siya, slanting on diagonal line ang gagamitin natin sa pagpa-plot ng 82.5 minus 120, which is negative 37.5. Lastly, straight line lang ulit, then add the upward force at E, so it will be negative 35.5 plus 37.5 equals to 0. That's it! Tapos na ang ating shear diagram. Before plotting the moment diagram, let's first solve the areas. To solve the first area, multiply the length and width as it is a rectangle, so negative 50 times 3 equals to negative 150. Since rectangle din yung shape ng next, length times width ulit ang gagamiting formula. So 82.5 times 3 is equal to 247.5. For areas 3 and 4, triangle sila, so the formula that we will use is 1/2 base times height. However, their bases are unknown, and to solve for it, represent natin ang base ng area 3 as x and area 4 as 6 minus x. Nanggaling yung 6 sa distance na meron sa uniform load. To solve for its value, use ratio and proportion. Shift solve x over 82.5 equals 6 minus x all over 37.5. The value of x is 4.125 and 6 minus x is equal to 1.875. Pwede na nating masolve ang area ng triangle. For area 3, 1/2 times 4.125 times 82.5 is equal to 170.15625. For area 4, 1/2 times 1.875 times negative 37.5 is equal to negative 35.15625. Then for the last area, we will use length times width. So negative 37.5 times 3 equals negative 112.5. Finally, we can now draw the moment diagram. You can pause this video and try to draw the moment diagram on your own, then we can check after if you got the same answer. From 0, draw a slanting line to negative 150. Hindi pa tayo pwedeng mag-proceed agad dahil mayroong given na counterclockwise moment na 120 kN, so it will be negative 150 plus negative 120, which is negative 270. After that, add the second area, 247.5, to negative 270, which equals to negative 22.5. Next, add the third area, which is 170.15625, to negative 22.5, and we will get 147.65625. However, since uniform load ito at positive decreasing siya, instead of using a diagonal line, we will draw a parabola that opens downward, o parang sad face. Next, add the fourth area, which is negative 35.15625 to 145.65625, and we will get 112.5. Since under pa rin ito ng uniform load, and positive decreasing siya, we will draw a sad face again. Lastly, add 112.5 to the fifth area, which is negative 112.5, for it to equate to 0. And that's it. Ganun lang kadali gawin ang shear and moment diagram.
Pwede na yun. Ganun lang pala mag-shear and moment diagram. Feel ko tuloy ma-perfect ko na yung quiz.
The next day.
Wow, perfect! Buti na lang nag-review ako.